Guys and girls, it's Noah time!
Alright, so the next part of this lesson I'm going to teach you is two things actually. One, I have to go over one more vocabulary word with you I didn't go over yet, which is coterminal. Now some of you know what coterminal means already, which is great. And finally, the last thing I'm going to teach you is something called arc length. Okay. I'm going to start with coterminal. Now coterminal really is just a formula. Coterminal angle. Coterminal angle. What coterminal angle really means is this. Find another angle. Find another angle such that the terminal arm is in the exact same position. The terminal arm is in the exact same position. That's what it really stands for. Find another angle such that your terminal arm is in the exact same position. For example, let's start out with an easy number. Theta something's happening, equals to 45 degrees. Draw a rough sketch of theta equals to 45 for me, please. Just a quick rough sketch, nothing more. This is 45 degrees. This is your terminal arm. What it's really asking you is, if I was to move my arm in any direction, find another angle such that it lands in the exact same position. And in order to do this, would you agree that if I move my arm all the way around in one full circle, I end up exactly the way it is? Yep. So this is why it's called terminal. So terminal arm really is theta, your coterminal, plus or minus 360 degrees. That's what it really means. Because if I move it clockwise, 360, or counterclockwise, I end up exactly the same position. So let's do this right now. So one coterminal angle is 45 plus 360, which is 405. We can do this again. There's an infinite amount of coterminal angles. So you go 405 plus 360. We can keep adding. There's an infinite amount of answers. 765. So guys, see, I'm going to highlight. This is coterminal. This is coterminal. And it goes on and on and on and on. Here's one way to ask you on an exam. Theta equals to 100 degrees. A, 360. B, negative 320. C, C, negative 400 degrees. D, 820 degrees. They're going to say which one of these is coterminal to theta. That's the exact wording they're going to say on exam. Okay. Remember, coterminal means you can have an infinite amount of answers, but one of these is coterminal to 100. Guys, gals, work with the person beside you, and let's see if you can find the right one. Okay. If you add 360, so let's try add 360. So go 100 plus 360, and sometimes say, hey, Miss Snow, 460 is not here. What they did is they add 360 one more time. Remember, you can do this as many times as you like. And they're all coterminal. If I do it again, your answer is D. Very nice. That's what they'll say in coterminal. If I work with radians, it's the same concept. Theta equals to 5 pi by 12. If I work in radians, the formula is theta plus or minus 2 pi. Because 360 is 2 pi. So guys, gals, I want you to find one positive coterminal and one negative coterminal angle. I'm going to pause it and let you just try. See, I'm going to use a formula. 5 pi by 12 plus 2 pi. I add 2 pi. Now, some of you are going to make the mistake by saying, hey, that's easy. That's 7 pi by 13. Guys, gals, please don't do that. My grade 8s do that. You shouldn't do that. You have to have the common denominator. So find the common denominator right now, which is 12. So this becomes 5 pi by 12 plus 24 pi by 12. It gives me 29 pi by 12. Very nice. Okay, nothing too bad. Yep, to do the negative one, you take 5 pi by 12, and we're going to just subtract it. Minus 24 pi by 12 gives you negative 19 pi by 12. Voila. Done. Coterminal angle. So now you should be able to do number 8. The last thing I'm going to teach you is something called the arc length. Arc length. And arc length is pretty simple. We're going to draw a little circle first. So let's put a dot in as mid. 2 lines. That should be in the middle. Arc length is basically the distance of an arc. I'm going to highlight this right now. This is my arc length. We'll call this A. Okay, that's your arc length. We're going to use blue. This right here, that's my radius. That's R. The angle, this little angle right here, is called theta. Now, this is called your center angle. Write a little star. This is where people make mistakes. Star. Theta must be, what am I talking? Be in radians. There is no exceptions to this rule whatsoever. Theta must be in radians. I'm going to give you an example. Find arc length. If radius is 10 cm and central angle, your central angle is 45 degrees. Guys, gals, I'm going to pause it, let you try this. There's a formula for arc length. That may help before you start. A equals to R theta. Bubble this. Very easy to remember. Or if you want to think about it, arrow. Arrow. That's your formula, arrow. A equals to R theta. So guys, gals, here we go. I walked around and I looked at only a few students work and I saw A equals to R theta, or arrow. And here's what I noticed. They went 10 times 45. And then they said, hey, mister, this is easy. That's 450 cm. But one crucial error. This crucial error right here. See, look, it says theta must be in radians. You can't just use 45. So what we're going to do is, let's erase that 45. That's a bad 45. You're going to cross out the 4, and let's figure out what is 45 degrees in radians, which is pi by 4. But I want to know as a decimal number. So let's use my decimal, because when you plug in this formula, they're going to need require decimals. Yep. Pi divided by 4. 0.7853. So we'll call 0.7854. 0.7854. You're going to put this in now into my bracket right here. 0.7854. And go ahead and solve it from here. Okay. Times 10, and you should get 7.85. So my arc length, given this criteria, is 7.85 cm. Voila.
Could you just leave it at 5 pi by 2?
Pi by 2. 5 pi by 2? Yeah, you could, but all your answer is going to be in decimals on the exam. That's why. Because when you measure arc length, they don't like to leave it as some word pi. Okay? Try another one. A bit more challenging this time. A circle has an arc length of 15 cm. Okay. The central angle actually, I won't say central angle, it's too easy for you. I'm going to make your life a bit more confusing. The radius is 5 cm. Find central angle in degrees. A circle has an arc length of 15 cm. The radius is 5 cm. Find central angle in degrees. Guys, gals, I'm going to pause it. You have 540 degrees? Wait, what? How much? 3 degrees? So, let's figure out this one right now. Let's write down my formula. I go arrow. A equals to r theta. So you can never forget that formula. Arrow. I'm given arc length. So this is 15. My radius is 5. Hey, they're looking for central angle. So they're really looking for is theta. Why don't we just take a minute and we're just going to do simple division. A lot of you did this and say, hey, Mr. No, theta equals to 3. That is correct, but this is a problem. My question asks you find central angle in degrees. This is 3 rads. What does that really mean? That just means the number 3, not 3 pi. It just means the number 3. So convert this to degrees. Convert to degrees. So we're going to take 3 times 180 over pi. Because remember, 3 is a number of radians, not 3 pi. It just means a number. So let's do this and see what we get. Clear all this up. 3 times 180 divided by pi. Drum rolls. 171. So Robert, you were correct. 171.9. If you want it around to 172, is up to you. 171.9 degrees. Because the number 3, remember, it means 3 rads, not 3 pi. This is called the arc length formula. A equals to r theta, and that's all you have to know.
Do you ever use the one where like you have to like do it over like the 2 fractions equal each other? Alright.
Your work complete. Page 60. All of 60. Everything now is fair game. You have over 20 minutes. Get crack-a-lackin'. And that ends our recording for today.